Yeah, so the topic of tonight is bull trout, past, present, and future. And the outline of the presentation, I'm going to go into a brief history on the, mainly a visual history of the landscape and the history of fishing and hunting in the area. And on to present, what's happening in regards to land use and current research, ACA fisheries inventory, data and collection throughout our forest management area. And then Jackie will be presenting on the bull trout food web analysis or native trout food analysis. And then I'm going to touch on a water temperature model that we've been developing to look at eastern slope water temperatures and best management practices for stream crossing construction and stream crossing inspection program. A few restoration stories of watersheds where we've made remediation to allow for fish passage. And then the future, it's the actions of today will write this story. So quick look at this settlement history. It's always good to look at your past and see what's been going on. As for forest management in our FMA, there's been harvest back before the 1900s, and 1908 timber berths were sold on auction and within Alberta. In 1907 to 1915, there was a Great West Logging Company operated west of Sundre up in the Blue Hill area, and they had camps on the Red Deer River drainage. Camp. The logs were moved into the rivers until in 1915 there was a very large flood that probably around this time of the year with the spring freshet, it ended up washing all of winter's cut into Saskatchewan. So that spelled the disaster for the Great West Logging Company at that time. So there's a lot of cabins built in Saskatchewan along the Red Deer down in the Badlands, built out of West Slopes, Eastern Slopes timber. 19 railroad ties were being cut for the Canadian Northern Railway lumber and fence posts and agriculture puts. In 1911, that's when the Forest Reserve formed. So then the 1920s was the beginning of sustained yield management for the Forest Reserve, the Clearwater Forest Reserve. So in 1923, there was 450,000 railway ties cut in the Rocky area by mills. 1927, there was a cyclone that devastated the town of Rocky Mountain House. In 1927, the Department of Forestry prepared a forest management plan for the Sundre Creek Valley. That's where they were cutting railroad ties again, likely for coal mine at Nordegg and other areas throughout the province. In 1928, Prairie Province demanded the control over fish and wildlife resources from the federal government. So that's in the few years later, the province took control over the management of forestry and fish and wildlife. 1930, the Forest Service created control of forests and wrestled it away from the federal government. So in 1930, the first oil wells was drilled in the Hunter Valley area in the Upper River. 1934, the Alberta Natural Resources Act was enacted. 1940s, over 1,000 men were employed in Rocky Mountain House area harvesting and milling trees. So it's a fairly large employer at that time. My grandfather actually worked in some of the mills around back when he was a younger man. 1949, Atlas reached its winter record of cutting 20 million board feet and 80,000 railway ties. So that was the main kind of the larger logging company in the Rocky area. 1955, Sonic lines were pushed into the backcountry for the impending oil field boom. And we can still see the evidence of a lot of those sidelines out there on the landscape now. They're slowly being forested, and the land base is changing. And then finally, in 1987, Sundre Forest Products purchased Revelstoke Timber operations near Sundre. So that's where timber management started for my company. So some of the new settlers to the area, this happens to be my great grandfather's homestead on the Tay, just a boundary. This is where my grandfather grew up, likely fishing the Tay River and fishing area streams. I've actually was lucky enough to get a copy of my great grandmother's journal, and she highlighted a bunch of the forays into the eastern slopes, fishing and hunting. Here's my great grandfather with some winter meat at the Tay Ranch. And sheep and goats were the main target species. Unbeknownst to most people, at that time there was no elk, and there was very few moose. So most of their hunting exploits, especially in the 20s, they were hunting mountain goats and sheep. And there's my great grandpa there with a bighorn ram. So, and likely most rivers where they camped and did their recreating had bull trout and Rocky Mountain whitefish. And one account that my great grandmother had was they were actually snaring whitefish for supper. So they weren't using hooks, they were actually snaring them. So that was kind of an interesting way of collecting your supper. And then on the other side of my family, this is my other my other side of the family, a Danish side. This is 7 Mile Flats, which is just on the Clearwater River at the base of Corkscrew Mountain. They obviously got into a mule deer there, but this was his first trip into the eastern slopes back in 1930. This again is my great grandfather on the Brazeau River, and they were actually doing some fishing there and prospecting or whatever the early guys did. At least enjoying the nice sunny day. And fortunately or unfortunately, this was kind of the way things were out there at that time. 1910. This is from the North Saskatchewan River, likely west of Rocky Mountain House. There's quite a mess of bull trout there. This is my my grandfather in 1909 at the forks of where the South Ram and the North Ram meet. They call that the Forks Cabin. This was unfortunately the day before one of their friends drowned in the river crossing back across during a high water event. And then another successful hunt. This was later on once the elk showed up on the landscape, 1950s. This is on the Bighorn Creek in the Yahatinda area. Of course, there's sheep, deer, and elk at that time. This is another kind of historic photo of the Drummond Glacier back in the day before, I think it was 1911, before the receding, the bottom picture, the bottom right there is the Drummond Glacier in the 90s, after you can see that the ice cap had severely receded. This is an interesting photo of Ram Mountain, which lies just north of the North Ram River. And that was 1940. Dingle took the picture in the geographic survey of Alberta, and it's pretty interesting to see what the landscape looked back then. The fires, the big fires had come through, and there wasn't much trees there. That was mainly aspen and small saplings at that time. And the valley in the forefront is the North Ram River, the meadows. So, back before harvest happened, the natural events changed the forest. You had the forest fire cycle, insects, disease, and also windstorms. And there you get the natural generation. Here's a historic example of what happened on the Clearwater River after the 1917 fire, and then on the right there's the Clearwater present day from the top, or the partway up Corkscrew Mountain. It's a pretty barren landscape at one point. Those only trees left there are those big spruce along the river. So here's a map of our forest management area with some fire history. The darker colors are the older forests, so, 180 years or older, and all the rest is all the lighter colors are up to present day, including all the fires from 1917, and you can even see part of the Dogger fire in the very southern part there along the Red Deer. Here's an overview of the Red Deer River when the Dogger fire came through in 2001, and the fire just burnt right across the river and leave a stick of timber along the edge there. So the current debate on buffers are they a natural process, or what are the benefits? And there's ongoing discussions with the scientific community, being the fact that, fire leaves pretty much nothing left. Here's a before and after picture of the same watershed. So this is another map of our forest management area. Our compartments or areas, harvesting areas, are broken up into watershed-based areas, which makes it pretty convenient for watershed management. The major river basins that are throughout our FMA are the Red River, James River in the south Saskatchewan, and then Clearwater, Prairie Creek, Ram River, and North Saskatchewan, Baptiste, and Nordegg, the North Saskatchewan River. So some of the current footprints within our FMA or oil and gas extraction, mining, forestry, of course, forest fires, recreational uses, roads, and grazing. So oil and gas extraction, they're up to well sites, seismic lines, pipelines, roads. Combined footprint is around 11,000 hectares today. And at the time, it was about 400 annually that was taken out of the timber production based on oil and gas extraction pipelines, but it's significantly reduced in the last 10 years with Shell Canada and other operators pulling out of shale gas in the foothills in our FMA. Mining, there's 3 limestone quarries within our defined forest area. There's one in Nordegg, one at Baseline, and then one at down on the Clearwater, and also the coal mining. There's grazing reserves. There's 1,035 head permitted in the FMA. The grazing season is from June 15th to October 15th. I believe this is on Elk Creek. And here's a map of the grazing dispositions throughout FMA. Forestry operations, we have timber harvesting, road construction, stream crossing construction, silviculture, reclamation. And the current fire disturbances I talked about before was the dog fire. It's currently 7,500 hectares within the FMA, and we've had 8,100 hectares since 1999 with the forest fires in our FMA. And of course, recreational uses, and that's definitely on the increase. With current COVID, there's a lot of activity out there in the West Country with camping. So the location of, where we've done most of our bull trout research is in the North Saskatchewan, Clearwater, and the Red Deer area. It's in the ES2 fisheries management area. So the map of our operation within the Red Deer drainage, This map depicts the full drainage upstream of Dixon Dam or Glenifer Lake. So it's 1,943 square kilometers are in Banff National Park. 1,362 are in our FMA, and another 2,294 are outside of the FMA in White Zone. And farmland clearing or clearing for ranching is 8% of the entire drainage within the Red Deer drainage. The FMA makes up about 20% of the entire Red Deer drainage above Dixon Dam. So currently we have 231 square kilometers of regenerating cut blocks. And that makes up to be about 4% of our FMA, the area within our FMA. All harvested areas are currently being reforested, and many of them, the trees are 3 meters tall or taller. Based back in the early 90s, are definitely reaching a pretty tall stature now. Within the Clearwater drainage, the total area excluding Prairie Creek is 2,252 square kilometers, and 49% of the drainage is upstream in protection in the Bighorn Country and Banff National Park. So there's 44% within our FMA. So the study areas that Jacqueline's going to be talking about are in yellow. So they're central southern part of our forest management area, and this summer she'll be alluding to where she's planning on doing some more data collection further north. So the scale or size of comparison of the provincial fish sustainability index, for bull trout, they're based on Huck 8, and it's at a 1, and Huck 10 is 1 to 250,000. So the studies that we're taking on are at a Huck 12 scale. So if you don't know what a Huck is, it's a hydrologic unit code, and it classifies different sizes of drainage based on there's how many drainages there are, and it's also based by region, sub-region, and then finally down to the sub-watershed level. So here's a list of the values that we can find within the original study area. As you can see here, there's land use practices and things going down the one axis, and the drainages across the top. Some have bull trout, or most of them have bull trout, but some also have brook trout and other species. Most of them have logging, and some of them have fire, and all of them have suitable habitat and then access, being cut lines or roads. They all have fairly good access, except for Rocky Creek and Pineal Creek, which are pretty remote. So habitat quality is key for bull trout, and I guess any other cold water species. They like cold, clean, complex, connected habitats. Bull trout require the coldest, cleanest water for spawning and rearing, and also for food production. And where the areas are located are very important to inventory, as we need to see what they're eating and where they like to live. And it's likely that not all reaches actually hold bull trout based on habitat quality. Throughout the years, Sundre Forest Products, or Sunpine at the time, has been very heavily involved with the Alberta Conservation Association in the CFIP program, which is the Fisheries Inventory Program. Since it started, there's well over 1,000 sites, so over 300 kilometers in stream length have been surveyed, and we hope to do more in the future. Data is pretty key when it comes to finding and finding these special habitats they rely on. And here's just a quick review of some of the historic data within the the drains that the bull trout study is in. You know, in total, there's quite a few kilometers of fish-bearing stream, but not all of them have high bull trout numbers. Brook trout, as you can see, are 584, where bull trout were 124. So scales are definitely turned. Here's ACA during some field data collection. And then more recently did North Saskatchewan River Drainage Fish Sustainability Index data gaps. There was areas where hadn't surveyed for some time, so we went back and actually resurveyed some of the drainages that were surveyed back in the early late 90s, early 2000s. For example, here we did Pine Needle Creek, and we did quite a few sites in there. So back in 2015, the results were that brook trout were outnumbered by bull trout 56-1. And there's 4 study sites and almost 13 kilometers of stream surveyed. And there was unfortunately no bull trout in the headwaters. And then in 2018 and 2019, ACA returned to Wilson and James drainages, and Wilson Creek, they captured 208 fish, including 83 bull trout, 119 brook trout. So there's kind of a bit of a shift going on there. And in Jackie's information that there's even more bull trout caught this year. Wild Horse Creek, 119 brook trout and 6 bull trout, and 1 possible hybrid. And we'll be talking about hybrids a little bit too. And brook trout were found at all the sites, and the largest bull trout was about 40 centimeters, so it could even come up from main stem red deer on a bit of a exploratory mission. Yar Creek, there was 87 brook trout and 8 bull trout and a possible hybrid. And the brook trout were all caught and the bull trout was caught in the lower section of the drainage. The South James River, there was no bull trout caught. It was all brook trout on the site. So fortunately, that's a little bit further down in the James, and brook trout seem to be holding their own there. And then these are, I guess, the location of all the sites that they sampled in the Upper James. Here's one of the ACA fellows processing fish. Nice day on the Wilson Creek. And this is the Wilson drainage here. Flows into the James just by the double bridges off the James Wilson campground. And again, another overview flight of the Yar Creek fire year after the fire. So I'll turn this over to Jacqueline, and she'll walking us through her study.
Awesome, thank you, Kelsey. So we see a few familiar faces here, but for those that don't know me, I'm Jacquie Pallard. I'm with the Fisheries and Aquatic Conservation Lab at the University of Alberta, led by Dr. Mark Bosch. So Kelsey gave a great overview of the history of bull trout, but I'm going to be kind of delving into what my study is looking into specifically. So that's assessing the effects of the non-native salmonids, such as the brook trout and brown trout, on the bull trout in Alberta's foothills, which is all within West Fraser's FMA. So you can jump to the next slide there, Kelsey. So what is the problem we're looking about? You've kind of gotten the idea already that bull trout abundances are declining all throughout Alberta. But the large issue is that the rate of decline of our freshwater species is actually going down much greater than our terrestrial ecosystems. So the need for their management has never been greater. So bull trout populations in Alberta specifically are expected to decline by over 30% in the next 3 generations, which is a huge amount. So bull trout are very important, if you don't know this, for as an indicator species. An indicator species essentially just tell you that a given ecosystem or watershed is healthy. So if they're not present, it could lead to a whole array of other issues underneath it all. So this map here on the right, I've put here just to show you that all the different watersheds of bull trout could possibly be present or have historically been present in. This was developed by the province and just shows the sustainability index of them and what the recovery probability is for each of the individual watersheds. But what is actually causing their decline? So you can go to the next slide there, Kelsey. It kind of boils down to 4 main contributing factors. The first being the habitat fragmentation and alteration. So whether that's road building, ATV use, recreational use, fires, etc. Competition with non-native salmonids, the brown trout, brook trout, angling pressure. However, given there's been a 0 bag limit on bull trout in Alberta since 1994, that's greatly decreased. And lastly is hybridization. So this is tied into the second factor there, the competition with the non-native salmonids. So brook trout are actually from the same genus as bull trout, so they can fertilize their eggs. Typically, with hybridization cases, you're looking at a male bull trout male brook trout going and fertilizing a female bull trout's eggs. So the bull trout are actually spending a lot more energy in reproduction and losing a lot more than the brook trout are. The brook trout also reach sexual maturity much earlier than bull trout, so they're really outcompeting them in a lot of ways. So the factor that we're going to be focusing on is the second one, the competition with non-native salmonids. So the objectives overall of our study are kind of listed here on my slide, but to put it in a better context for you, what we're trying to answer is, how are these species interacting when different resources are present? How are the bull trout utilizing their environment with and without competition? And how can we best manage fisheries to counteract these possible negative interactions that these non-native fish are having on them? So what we really hope to create is a suite of characteristics for these headwater streams in the foothills to create a priority watersheds for recovery for the bull trout. You can jump to the next slide. So Kelsey kind of went over a little bit of where our study is taking place, but I can delve into a little more for you. So what we've done is selected 12 different streams within their FMA. We've split all these 12 streams into kind of 6 different treatments, like I would call them. We've selected 12 of them to have 2 replicates of bull trout dominant streams, 2 brook trout dominant streams, 2 streams that are brown trout dominant, which are very hard to find at times. And then our streams that have predominantly bull trout and brook trout, then ones that are predominantly bull trout and brown trout, and then streams that are kind of an equal mix of all 3 species. So if you look on the map there on the right, you can see that the sites kind of in the pink and red gradient are all the streams and sites we sampled last season. And that this year we're planning to do 5 more, which are noted in the green gradient there. And you can see they all, one way or the other, lead into the North Sask or the Red Deer River drainage. You can jump to the next one, perfect. So we've split it up, the study, into 2 kind of main components. We'll have our habitat component and our dietary component. So at each site, we're electrofishing, but we're also collecting a whole bunch of other data. So for the habitat component, we are conducting surveys that look at things such as the percent of pool riffle run, percent of different substrates present, like your your fines, your silt, your gravel, your cobble, measuring temperature, which has also been supplemented by Kelsey and all temp loggers for all over the FMA. And then other things like large woody debris, canopy cover, etc. Then we'll also be extracting land use data from GIS. And then for non-statistician, it's called logistic regression analysis. But what this is essentially doing is taking all of your habitat components and then comparing it back to our electrofishing catch rates. And then we can essentially compare models from our bull trout dominant streams to our mixed streams to see if their habitat use is differing among the different streams when there's different levels of competition. And we can really tease out what these bull trout are doing if they're under competition, if they're changing, if they're just staying the same and being outcompeted. So that's going to be the really cool part to get from that. And then as far as the dietary component goes, you can jump to the next one. We also electrofished to obtain fin from the caudal fin. So that's the tail, and we take it, the tissue from the top part of the tail. And this is going to be used for our stable isotope analysis, which I'll get in a little bit later. But we're doing that essentially just to compare that and create a whole food web analysis. Then we also gather a whole bunch of other details from the food web. So things like your stonefly in the top right here, which we collect using kick samples, which is essentially just putting a big old net in the water, kicking upstream of it, loosening up all the rocks and debris and the invertebrates, and they fall into your net from the stream, using pan traps to collect your terrestrial invertebrates, and then hand picking of your periphyton, terrestrial, and aquatic vegetation. So by collecting all of these components, it allows us to fully understand the trophic interactions and actually like the fine skill details of the food web itself. Can jump to the next one, Kelsey. So you heard me mention stable isotopes a few times. So I'm going to try to give you a quick basic overview of what that actually means. So all tissue, whether it's from plants, the fish, the invertebrates, have levels of carbon-13 and nitrogen-15, which is noted in the graph here. So stable isotopes, you can use them to map energy flow through food webs and determine trophic levels, see what fish are consuming, determine levels of competition, and it's just very popular for ecosystem management. So nitrogen-15 is a compound that compounds as you move up in the food web. So this brown trout on the left, as it eats fish, all the fish will have a lower level of nitrogen than it does that it eats. And same with a fish that's eating a bug, its nitrogen in the fish is going to be higher than the nitrogen in the bug itself. Versus if you look at carbon-13 here, that doesn't compound as you move up in the food web, it stays stable, which allows you to essentially place some fish over certain families or species of other fish or other bugs or certain plants. So it really lets you tease apart the entire food web and really let you zoom on in what fish are eating and comparing that among the species to see if maybe the bull trout and the brook trout are consuming the same things, or maybe they're consuming entirely different things and they're not competing. So that's what this portion of the study is going to be looking at. And that pretty much sums up for the methods there. So we'll jump into some of our preliminary results there. So all this data collected last year is all kind of a basic overview of what we have at the moment. It hasn't been delved into statistics too much, but we're hoping that at least you can see some cool, interesting results from what we do have. So this one in particular is just showing you what we caught last year. So you can see at the top here, we have all the streams that we sampled: burnt timber, elk, pine needle, etc. And then as you go down the right, it lists all the species that were present and that we were looking for. So your brook trout, your BLBKs, which are your potential hybrids of bull trout and brook trout, your BLTRs being your bull trout, BNTRs, brown trout, and and MNWH is your mountain whitefish. So just looking at this, you can see that burnt timber, we only caught bull trout. And relatively speaking, mostly smaller bull trout, sub 150 millimeters, except for some few larger ones that Kelsey helped us get from his fishing. And then you can see at elk here, we caught all 3 species, but still predominantly bull trout and brown trout over brook trout. They're a little harder to find and you had to target them a little bit more. And as you move over, pine needle only having brook trout mostly. I think we caught 1 bull trout there. Same with Yara. And then look at Rocky here, only having the bull trout, and that was courtesy of Alberta Parks and Environment. And Wild Horse and Wilson, both having bull trout and brook trout. But kind of comparing this back to what Kelsey was just saying, Wild Horse used to historically have a lot more bull trout in it. So when we were going in it, we were expecting to have a much more 50-50 mix of the two, when really brook trout have fully established themselves there and really seem to be outcompeting the bull trout in that stream. Versus Wilson, you're looking at the kind of the shift where Kelsey was saying it was a lot more brook trout than bull trout, and now bull trout are kind of equalizing the playing field there, if you would call it that. So that just sums up what we are catching this year and their sizes, and would at least tell any of you anglers where some interesting streams to go to, depending what you're looking for. So we can move on to the next part here, which is just kind of a quick summary of what we were seeing habitat-wise in our streams. This is only a very small picture of it, but the first here on the left is our water feature averages. So this is just showing how much riffle, pool, and run were present. So you can see overall, riffle really was the predominant feature in all, like most of the streams, except for, I'd say, elk, where it had a lot more run. And on average, run was also in higher amounts than the pool was. And then if we go to the right here, we're looking at our substrate averages. So our silt, sand, gravel, cobble, boulder, and bedrock. Also with the small pattern here of cobble being the predominant substrate in all of the streams, and kind of with all of the other ones varying in the reach it was or in the stream it was. So all of these values in both of these graphs were just averaged over all of the sites that we collected. And lastly, that the gravel was kind of relatively stable throughout all of the streams there. You can go to the next slide there, Kelsey. Thank you. So next we have our invertebrates. So I mentioned the kick samples earlier. What we're doing is collecting a kick sample in the pool, riffle, and run of each of the sites that we electrofish. This gave us a really broad overview of what every site can contain for families, which allows us to give the entire food web, or a picture of the food web. So we actually collected over 9,000 invertebrates and identified all of these down to their family, which took quite a bit of time, but very interesting. And we're just sending that into the lab now to be analyzed. But at least what we have for you at the moment is how many species and families were present at each of the streams and what the variation was like. So I don't know if everyone here has immersed themselves in box plots as much as I have, but if you haven't, I can give you a little quick overview of what this actually means. So the solid line that you'll see on each of the boxes is a bit thicker than the entire box itself. That's telling your median. So that's your middle number in your whole array. So if we collected, say from burnt timber, 8 different kick samples, then this one would be the 4th or the 5th number in that data set. And then so on for all the other ones. But what you can really see here is that burnt timber had some major variation in the numbers of families present in all the kick samples. So we had as little as 6 families in some and up to 15 families in others. Versus if you jump over to the far right, Yara in the green, you can see there was very little variation and like a pretty steady number of families per every kick sample, which is really cool to compare and see that there's that much variation, which will really tie into the spatial variation in streams and seeing what competition is happening there. And we can jump on to the last slide here on my results. So this is very preliminary for our stable isotopes, but still very interesting nonetheless. So this is showing what I talked about earlier, the isotope of carbon-13 on the left axis, and the species on the bottom here, and the streams on the top. So you can see all the species are also noted by different colors of boxes, bull trout being green, brook trout red, and your brown trout in blue. But what's really great or like cool to see is that in elk here, where all three species are present, there is some major competition for resources going on. So as a reminder, carbon-13 is that isotope that isn't compounding, that is staying stable in the food web and can tell you what individuals fish are consuming. So you can see the bull trout and the brook trout here, they look like they're pretty much consuming the same thing. So they are really competing for the same resources. The brown trout are still competing with the bull trout, not quite as much though. They're not actually competing a whole ton with the brook trout. And then we can also jump and compare here burnt timber and Wilson. So burnt timber, as I mentioned earlier, is a bull trout dominant stream. We've caught no brook trout there, versus Wilson is that 50-50 pretty much mix of your bull trout and your brook trout. And you can see that the little whiskers, these little tails, the thin part that come off each end of the box, aren't overlapping between the boxes of burnt timber and Wilson, showing that either they're consuming much different things in Wilson than burnt timber, whether that's due to competition and they're switching resources, or maybe those resources that are present in burnt timber aren't present in Wilson and they're going to utilize different things, which is what our further analysis is really going to tease apart. So that's kind of just the quick overview of the stable isotope analysis and a little bit into the habitat. There's much more to come, but as far as what is next, we're going to repeat the methods. Oh, sorry, Kelsey, you can jump to the last one. For an additional 5 streams, which I said earlier, this is really just to strengthen the study and get replicates of each of the treatment types. And we're really just hoping to gain a better understanding of the species. Without management, unfortunately, like we may see the loss of Alberta's provincial fish. They are super important as indicator species, powerful indexes for species richness and ecological functioning, and losing them would be an immense cultural, economic, and ecological loss. So that sums up my presentation. Also big thanks to AP, ACA, and Kelsey and everyone from West Fraser for all the data, all of the good fishing holes from Kelsey as well. So I think that sums me up here. You can continue onwards.
Thanks, Jackie. I'll just we'll go for a question after my presentation. So I guess I could have taken the slide out, but this was Jackie's questions. So I'm quickly going to go over just as Jackie alluded to the hybridization of brook trout, and I guess you guys are all fly fishermen, so you should be able to, you know, I'm pretty sure everybody got 100% on the fish eye quiz. Yeah, but anyways, vermiculations on the dorsal on the back. They have dark spots on the dorsal. The tail is dark around the outer edges with dark lines, and dark lines between the white leading edge and the pectoral fins. So this is a small brook trout from a pond. And the dorsal fin brook trout are square and lots of dark markings, vermiculation or worm-like markings. Here's a very large brook trout from the James River. It was 6 pounds, 12 ounces. Lived in a beaver dam. And note the square tail and the presence of a lot of dark. Here's a small stream resident bull trout. I think this one was actually from Wild Horse. And then the bull trout do get very large. This is bull trout from Falls Creek drainage back when we were putting transmitters in them with the ACA back in the mid-2000s. This fish was angled, and then we did surgery on it and implanted a tracking device. This again, another small resident bull trout. Bull trout tails are shaped similar to this. Note that it's not completely flat on the end, got kind of a V. And the caudal fins are more opaque with no black markings. Here's a James River bull trout and the similar habitat throughout that reach. And then the dorsal fin on the bull trout is crescent shaped or shark fin like, and there's no spots and quite opaque. Here's a hybrid caught out of the red deer. Another one. Note shape is quite a bit, looks kind of like a bull trout, but you're seeing the spots there. Close up. And here's a hybrid actually from possible hybrid from the burnt timber, which is also kind of alarming, being that we did, Jacqueline didn't catch any brook trout in electrofishing, but obviously somewhere in the drainage there's something going on. So a description of a hybrid: dorsal fins have pale spots or vermiculations. They don't have a squared tail. Heads are not long and sloping like a bull trout. They have darker edges on the fins, blue halos, and it's a trout trig, and replaced by purple or pink spots. The tails have spots or either light in pattern. And just to confuse things, there's a dorsal from a lake trout, so they're also could be confused if you don't know the characteristics to look for. So what I'm going to talk about now is the water temperature model that Sundre Forest Products and our sister company in Hinton have started with a contract hydrologist, Ryan McDonald. And we're lucky enough that we've have had 5 years of water temperature collection data. And we also were able to get partner groups like ACA and U of A, Trout Unlimited, and some of the government of Alberta sites, and they've supplied their data. So in total, within our two FMAs, there's 244 sites in total for multiple years, so up to 5 years and as little as 1 year. So the loggers that we use, they're called, they're a automatic logger. They're placed inside the stream and they take a temperature every hour of every day after they've been deployed. And we use the data to create a spatial statistical model of all the drainages throughout our FMAs and surrounding watersheds. And ultimately, in the end, we were able to get an online viewing portal for anybody that's interested in seeing water temperature results. So we had them in many different places in our FMA, but mainly in the areas we were doing the bulk study for the first few years. Now I'm going to be moving them to other drainages further north. We'll be putting temperature loggers in the 5 drainages that Jack talked about today, the expansion of this summer's field season. We put them mid-basin and then also close to confluence. So we can see the difference between the water temperature at the receiving water body and mid or in the upper drainage. In the case of Wilson Creek, we had 4 logger sites that we maintained for maximum coverage, and a minimum of 2 per drainage. And Hinton Forest Products had loggers in similar locations throughout their study areas. So this is how I deployed them: is I took masonry screws and screwed them to rocks and put them in these ABS, and then put them in the bottom of the river. Here's the actual upper section of Wilson Creek. Here's a wild horse. Here's trout in site 1 on Yarrow, which is just above the Red Deer. Unfortunately for this guy, the river was completely dry for 500 meters below this pool, so we were in the low scenario. So he was stuck there for the winter. This shot of Pineal Creek. The upstream logger site is just where they was there. And this is a picture of the lower site towards the Clearwater. It's 800 meters from the Clearwater. So this was an interesting one. The stream temperature data for 2017, summer of 2017. The upper Pineal Creek was actually warmer than lower Pineal Creek by a few degrees, which is likely caused by groundwater influence. This is a site on Lower Rocky, and there's a mid site on Wilson Creek. Logger locations are on this map, and it also is overlaid with all the fisheries collection permits. The other sites are in green. And what else? The other things that we did is we looked at tree heights, forest cover in the spatial statistical model. This is happy the Wilson drainage. We also took elevation, slope and aspect, and slope direction. And with all those climate variables and landscape variables, Ryan was able to piece together a conventional model on how to display mean monthly temperatures. I'm going to actually go through to this. This is fairly detailed. This is a representation of the data export that comes right out of the online portal. So we can bring it into our GIS system in our ArcView and analyze each of the reaches. And the study drainages, this is the timber, wild horse, Yarra, Rocky, and Pine Needle and elk. So this is the link to the online viewing portal that anybody can go and look at water temperatures throughout the eastern slopes. So the study area goes from north of Hinton by Grand Prairie all the way down to just down by Pincher Creek. And there's a bunch of the statistics that Ryan put together to show the variability and the predictive nature of the model. And here's water temperatures. So this is the interesting thing about this this box on the left here is you scroll this bar, you can actually see the temperatures change month by month throughout the whole year, and it actually graphs them by month. So you can actually close up the range if you want to look at all the warmest water throughout the season. You could do that, or if you want to look at the coldest. It has a lot of functionality, and all the data with this special login code you can download and view it in your own GIS systems as well. So now I was going to get in just a quick thing on stream crossing best management practices. Clear span bridges, especially when it comes to bull trout, are our preference. This happens to be the Wilson drainage during our first pass harvest before we put the bridge in. This is after, and that bridge was actually removed. It was a temporary bridge. So planning and with best management practices. So our environmental management system developed all of the best management practices for watercourse crossings. First of all, especially with the use of that ACA data and stuff that's found within FWMS, we identify fish-bearing streams ahead of time. We do pre-construction crossing assessments to identify other fish habitat values, and we've been doing so since 1994. And with the use of our peak flow model, we size the crossing, culvert, bridge to the proper flood levels for 1 in 100 for the long-term roads, 1 in 25 for temporary roads. Design of bridge crossings based on that calculated flood level. Bridges provide the best alternative for fish-friendly crossings. Sundre Forest Products has a very high bridge densities on, throughout the region. It's 1.1 bridges per kilometer and 2 culverts per kilometer. So, your number of crossings to get the water across the road safely increases the connectivity of all the water courses. Bed and armor your pipes or culverts, install baffles, and fill with substrate to allow fish passage. That's a best management practice. We rarely do this. We would prefer to put a bridge in instead of a culvert because it's timely and there's a lot of maintenance to do with bedded pipes as well, to removing excess debris and blockages and beaver dams and all kinds of other things. So, and at the time of doing the pre-construction assessment, we prescribed erosion control structures and temporary crossings to build them. So on to our stream crossing inspection program. We've been inspecting and post-construction since 1994 as well. Inspections are done on an annual basis after flood events, especially if we've had some big floods like 2005, 2012. There's an FMA wide coverage to make sure that we don't have any crossings that have failed. So that's 3,100 bridge inspections, 10,000 culvert inspections, and these are some of the breakdowns of what we find for outages. External damage, that would be either cattle, quads, on highway vehicles going through the streams. Reinspect is the vegetation is coming, but we'd like to make sure that it's fully vegetated. Repair and satisfactory, and that was for the last 3. And this is a graph of all of our past inspections back to 2001. So we keep pretty close tabs on how our crops are performing. And that also feeds back into your best management practices for construction, is see what's working and what's not. And ultimately, in the end, we want fully reclaimed crossings, and they're going to provide fish habitat. There's this stream here has got willows in already, and provide all the hiding cover they need. So some of the other issues that bull trout are facing are increased access, people going behind gates. Of course, there are common issues with quadding. These derelict seismic lines that, he's taking responsibility to maintain, you get erosion starting at the top and going right down to the bottom. This is actually in the Falls Creek area where AEP started reclaiming the crossings. I'm pretty sure there's grass growing here now, since then they're actually going to walk it next week to look at the revegetative success. And then within the Falls Creek drainage, specifically, SFP has updated, the trail networks with the trails that are proposed, forced, and ones that are no longer required. And it was determined that certain lines should be reclaimed. So after we were harvesting, we would site prep through them and reforest them. So for example, just with Falls Creek drainage, we've taken out almost 10 kilometers, 3.1 within cut blocks and 2.2 out of cut blocks. And then at the time here, we're going to do 4.2 more kilometers, which we've completed. And some of our deactivated roads might replace some of the trails, but ultimately, this area doesn't see much more use. Here's just an over map of some of the trouble trails. There's mud holes and huge erosion, and leading right down into Falls Creek. Here's Falls Creek after a couple hours of quad crossings upstream. It's just a big silt plume, and actually today in particular, one of the fellows from ACA were snorkeling below the falls, and the visibility to count bull trout, and the visibility was so bad he actually had to quit that day. It's kind of unfortunate. So this is another thing that we see in the West Country with the higher gradients and extreme weather events and flooding. During extreme floods, channels have moved up to hundreds of meters of floodplains. We've seen that on the Clearwater, the Rig Street area. We've seen that in many locations on the North Ram. All tributaries get moved with shift habitat. Most events are caused by localized flooding, i.e. thunderstorms, or they're usually not caused by yearly runoff. It's a hailstorm or something like that. And what are the implications on a low density fish population like bull trout? Here's the actual Clearwater during flood, just upstream of Corkscrew Mountain. You can see how it's braided and across the whole floodplain. Here's Upper Pine Creek, one of the creeks that's in our study area. Unfortunately, in 2012, this stream got a real boring from an event. The stream is in there somewhere. It flooded all the willows and filled in a lot of the habitat. Here's an ortho overview of that channel 2001. That's what it looked like in 2014. So this is outside of any timber harvesting areas, just directly from runoff. Here's another example on the Clutter headwaters, just downstream of Washout Creek. And all the drainage is in prime protection or outside the industrial footprint. This particular hole has been stable for 50 plus years until 2012. The water depth before the filled in was approximately 10 feet. And there's the location just below the washout. This is the hole in 1965. That happened to be my grandfather, a little angling there. 1985, beautiful hole. 1998, 2001, you see a little bit of encroaching, and then it's completely gone. The river rerouted and missed that probably a pretty important overwintering hole. So fish passage barriers, natural and man-made. So throughout our FMA, there's 55 barriers known that are not on SFP roads. Some of them are on Alberta transportations, and to their credit, they've fixed 3 in the last few years. I think with the coaxing of AEP, they fixed a couple on the James and McHugh Creek, which is good to see. And the main culprit is that I've seen on county roads is undersized culverts, which with perched outlets. So what happens there is when your culvert's too small, it's like turning the garden hose on a bore, and what it does is it just erodes all the soil up below. Another thing that we're seeing a lot of, especially with all the extra recreation out there, is rock dams. And some of these other hanging culverts and fish passage barriers, we've inherited and we've repaired them. Here's a rock that I pulled down on Wild Horse Creek this fall when I was going to pull my temperature logger. This was done in September sometime, or September or late August. And that's just right when the bull trout would be coming out of up the Red Deer to maybe do some spawning in the lower part of Wild Horse Creek. And here's Rocky Creek. This was actually in October. and completely dammed off as well. There's a little bull trout stuck in the upstream side there. He might have just froze to death. But I opened up the dam there and he could back down to the clear water. Here's a diagram of the definition of what a hanging or a perch culvert is. So anything that's as a plunge pool below, and you have a distance, the outlet gap to the top of the pool is greater than 10 centimeters. So there's determining the risk facts within the culvert is this is one that the province put together to determine which ones should be repaired, what's happening within the culvert. Here's a properly built crossing. This crossing is 20 years old. It has an embedded stream bottom in it. Fish can definitely cruise right through. So if you put it in right the first time, culverts all have a lifespan. So it's important to think about that before putting them in on long-term roads. And temporary work bridges for some of our major projects here, we're putting swamp mats on the gravel bar on the north ram for our Pinto Road bridge crossing on the north ram. And here's our temporary crossing. And then you remove all the rig mats after, and that's what it looked like after we were done. And then after the construction or reclamation of crossings, effective erosion control on our deactivated and active crossings is very important. Using jute or runoff controls like stem logs. And of course, the best remedy for erosion is extra grass seed. Here's a Cripple Creek tributary. We were going to take a road over from Shell Canada, and in order for us to take it over, we decided that we'd jointly fix the culvert. As you can see in the bottom right picture, there's the hanging culvert, and there was 8 meters of fill over top of this culvert that had to be removed. And this is the fisheries assessment they did below, so we knew the fish were up to where the culvert was. They actually misidentified it as a roe trout, which I can guarantee it's a cutthroat. And then after removing 500 cubic meters of fill, which is 250 gravel trucks full of fill, the old culvert was moved. We built a new channel and drove piles for the bridge. This is the setting of the bridge. And then after the following September, ACA and I went out there and electroshocked, and enough we found fish above the hanging perch. It's nice to see those guys reclaiming up to 3 kilometers of extra stream length. This is actually on the Dry Creek Road, on the headwaters of Prairie Creek on Dry Creek. There was a chronic hanging culvert on one of the oil and gas roads that we inherited, and we pulled it out and put this bridge in. Other structures other than does it work are envirospan bridges, where you span the whole channel and you're not actually putting anything within the channel. So it does the same thing as a bridge, and they're better for the smaller watercourses. And these envirospan crossings are also very portable and easy to use. I think we have 12 of these now that we use on a temporary basis. And they're fair, you put down the geotextile, and after that's done, everything leaves, and the undisturbed stream channels that are still there. Here's a OA trail that we built one of our roads down, that we removed a barrier on a small permanent. This is the creek after the barrier was removed, the 20-foot bridge. And then some we've remediated by putting a little bit of ballast at the bottom to back flood the channel to allow for the fish to get through. Here's another stream on the James. This is just up to the James Wilson campground. This had been hanging for 30 plus years. Actually, Alberta Transportation, it was their gravel pit. And unfortunately, the fish had a hard time getting up. They could never do there. So we replaced it with a bridge, and we haven't shocked it yet, but it's in the works to plan and electric to see if they're getting access to the upper part. Here's one of the lines that we did is on the Tay River tributary. This is before the repair, and this is after. So reconnecting streams within the FMA. Recently, we've joined on with the Trout Unlimited Canada initiative, Connecting Canada. We're a supporting member. So within our FMA, we prepared drainages on Swale Creek, Wigwam, James River, Dry Creek, Prairie Creek, Tay River tributary. So it equals up to 30 kilometers of fish habitat made available on gradient and stream flow. So, all these values need to be evaluated to get a clear on each sub-basin and capacity to support healthy fish populations at a scale that we manage our infrastructure to. So here's some links to additional information. There's some links to the Alberta Conservation Association's publications about fisheries inventory. There's also some things about Trout Unlimited Canada reconnecting Canada partners, and there's another thing on Alberta Conservation Association bull trout work that we've funded in the past. So one last fish story. I'm sorry to keep you guys a little bit later. I underestimated how many slides I was going to put in here, but this bull trout number 62, it was tagged in 2008, and it was caught again in 2017. So when it was caught back in 2008, it was 18.8 inches, and when it was caught in 2017, it was 30 inches. So this was at least 14 years old. So it's nice to see that this girl probably did a lot of spawning on Falls Creek. So with that, is there any questions? Jacqueline, are you still there if you get any technical questions on your study?
Yep, I'm here for those.
Okay.
Kelsey, Don Anderson here. When you mentioned grass seed, what kind of, like the reseeding in those areas there, would you try to use native species? Or is it?
We've got a cover crop where we're allowed to use an annual cover crop, which is Italian rye, and stuff will grow on in your bathtub. So it works pretty good. And we've seen that native seed comes in 2 to 3 years later, as long as it's got a good cover crop. So, and then
I had that experience. Like we wanted to use native stuff when we were working on Stoffer and some of the other creeks, on Clear Creek and so on. And it was really, really hard to get native, like grass seed, and that was really tough. That's the reason it prompted the question. I was just curious what you guys used, because it used to be all forestry mix. Remember that?
Well, well, this is a version of the forestry mix, actually. But we're allowed to want the cover crop though, and sometimes other industries have used clover as a cover crop, and that attracts the county did that's what all the deer and the bears were hanging along the North Fork there, right? So it does attract the wildlife for sure. But I would like to be the fastest growing thing to get stuff greened up, right? It's critical.
Yeah, stabilizes it real quick too.
Yeah. Last year we I think we used 80 bags of native grass seed.
Good Lord.
80 bags. So that's how much grass seeding goes on. And that's you can we're seeding all the crossings right on reclamation. So
Thanks, Kelsey.
yeah. Is there any other questions? Well, I see there was some in the chat there. Did you see those? Jackie?
Yeah, it was just on the being the hybrids, were they fertile or not? So.
Right. Oh, and then I guess you answered it. So I guess.
But if anyone didn't read the chat there, it's that most often they are not fertile. So these hybrids that are produced, like, don't often reproduce. Very rarely they can, but their reproduction ability is usually greatly reduced. So really, you're really just more looking at the loss of bull trout eggs and prevention of the species from contributing onto their full potential at that point.
Jackie, how common is this hybridization thing? The reason I ask is I fish a lot, and I fish a lot of places, and I think I've only found 2 of them in all the years where there's been bull trout, brook trout crossing.
Mm-hmm.
How common is it? And you need a very special place, don't you? Like, there's few, if any, bull trout, for example, in Prairie Creek. But there's tributaries to some of the streams north of Nordig that have possibilities. But a lot of places, boy, it's got to be pretty rare.
Yeah, it's just speaking from, I guess, what I've read and what we have. It really isn't extremely common to see the fertilized eggs turn into hybrids, but where they are, at least what I'm seeing, is they're kind of coming in pockets. Like where I was catching hybrids, I caught 3 hybrids in one spot. So it might just be the habitat suitability is where they're competing or whatnot.
Or it was a really horny little brook trout.
Yeah, it was a really competitive male looking to get out to all the ladies.
Competitive is a nice way of putting it. But,
yeah, because it really is those males going in and getting all those female eggs.
But
so.
you think about it, like the bulls, they spawn what, the end of August. And the brookies, at least my experience is, we're looking at the end of October, which is a pretty wide spread. So you think there wouldn't be a heck of a lot of them, at the end of the day. One of the comments I run into regularly is the comments from various people saying fishing pressure. And what I find most interesting about that, the fishing pressure by law-abiding citizens on bull trout is virtually non-existent, other than people with their damn cameras killing them. But the other types of fishing pressure are directly related to government. The government doesn't require the people to recognize species. The government doesn't do dick shit about poaching, or very little. And so on. So you take a look at a bunch of these problems that are directly related to how our government manages the illegal capture and retention of bull trout. The law-abiding anglers, by and large, have done their part. There, I've climbed on my sermon. I'm done.
No, I would. Kelsey and I always talk about this, how there needs to be a lot more education for novice anglers getting into it who don't know how to identify or refuse to identify, and a lot more enforcement of that to ensure those bull trout really are being put back. So unfortunately that is not always the case. So
but again, this is a responsibility of our government to make sure that the people that are out there know what they're doing. What always fascinates me is how hunters are required to identify the species, how many horns it's got, what time of the day they're shooting it, all at the same time while it's doing 40 miles an hour through the bush. And here we get fishermen, they can look at this damn thing and they have a map, an actual booklet that shows a picture, and they still can't figure it out. So it tells me that something is wrong here when hunters have to be asked all these questions and fishermen are assumed to be so much stupider, something's wrong with it. Again, I'm crawling off my soapbox. I mean, it just irritates the hell out of me that we don't ask more of our government in terms of what we should be doing around fishing. You know, I mean, fish don't have any petting qualities, if you know what I mean. They're not furry and all cuddly.
People don't love to save them as much as they do the furry ones, so.
Is there any good success stories on bull trout? Like, you know, in some of the areas of southern Alberta, I think the population's actually going up, I suspect. Like, it's not going down everywhere, is it? That's
I can't say myself, Kelsey.
Certain areas are definitely doing their own, and you know, they've probably been historically good blowout areas, and the reason why they're probably made that way is because they're a little bit harder to get into, and access is a little, you know, tougher. So, you know, they're not right just forestry trunk road. So, you know, I think there's definitely pockets of pretty populations. For south, I'm not so sure. There's probably more angling pressure, especially on the upper Oldman and Dutch Creek and in that area. Like, for the amount of hooks crushed in that over a summer, you'd think that every fish would be dead if hooking mortality was, you know, issue, or you know, if the majority of people are treating them properly, I think, you know, for the most part, they do well.
Well, that area tends to have traffic of a different type than some of the other areas, Kelsey. They
Right.
tend to be more fly fishermen entirely rather than the mixed bag you tend to get. I hate to be elitist, and that's what it is, but it would appear like that's the case. They tend to take a little more care, it seems.
Right. All right. If I have any more slides here or any more fish stories, so you guys, I don't know. You guys usually shut it. I think we're overdue here a little bit, but I can. Obviously, did I quit sharing screen? Yeah, I must have. So.
Yeah, it's close to 8:30. That's kind of when we wind things up. So I guess I'm just going to say this is your last chance. If you've got any questions, to speak up now and maybe stand on your soapbox.
There you go.
Well, you're predicting 30% drop in bull trout numbers. Where is that going to come from?
Sorry, can you repeat that? I didn't hear the beginning of that.
Pardon me?
I said, could you just repeat that? I didn't hear the beginning of it.
I can't quite make you out.
Wasn't that in one of your slides, Kelsey?
It was one of Jacqueline's slides about
Was it that where it was?
the forecast.
Yeah,
What was the
forecast.
question? I just didn't hear it.
The 30% decline in bull trout in the next 3 generations question.
Oh yeah,
He was.
It would just come from what is unfortunately currently there, which is not a lot. So.
In fact, it's pitifully few.
Mm-hmm.
Hi there, can you guys hear me?
Yeah.
Oh, perfect. Okay, great. Just a question for Jacqueline. Looking back to the stable isotope results for brown trout, is that what you expected to see based on studies in other areas? And similarly with your brook trout to bull trout results as well? Is it kind of similar to what people saw in the States?
For the brown trout, yes. Like they typically I don't know, I expected the brown trout, like yes and no, to be a little more competitive with the brook trout, because they've shown in the States that brook trout don't usually do as well when the brown trout are in there. So the fact that they weren't really competing or consuming the same resources is interesting. So it might really just be more to do with habitat at that point. Particularly like stream temperature seems to be a main driver of when brown trout will kind of override the brook trout in a stream. As far as the brook trout and the bull trout competition goes, I feel like that is not really surprising to me, given whenever you're seeing those brook trout infiltrating, you're usually looking at quite a big loss of the bull trout in a lot of those streams, particularly like if we look back at Wild Horse, which had such huge numbers of bull trout historically, and then a couple years later, even I feel like 2 years later, sampling, there's just way less bull trout in the system. So
I have a question about that term competition as well. So how do you know that they are competing? Because competing means that the resources should be limited, right? Like there's not enough food in the buffet for both species for them to be actually competing with each other. So like from your data, you can certainly say that they're eating the same thing, but if there's still a full buffet, you know, invertebrates aren't limited, then is competition really a problem? Or how could you ask that question maybe using your data? Does that make sense?
no, yeah, that makes sense. I think what we're trying to more like decipher is what resources are potential competition factors, not if, I guess, they are fully competing for that resource, but if there are potential resources that are gonna act as these limiting, constricting factors on them.
Okay, thank you. Good answer.